And hello, welcome YouTube to this video. So this video is a continued code exploration from the last time. And the last time you were trying to figure out how these Jacobians were constructed. And very important part of this, how the Jacobian matrix is how the Jacobians are constructed are these positive and negative coordinate systems. Okay, how it'll be interesting and very important to see how these positive and negative coordinates for each of these partial derivatives within the Jacobian, how are they constructed. Okay, one more thing I just found that you see here, there's a little bit of a mistake. I forgot to put the partial thing at the bottom, so I will need to do that right now. Okay, after that let's take a look at the source code. Okay, but let me correct the typo first. Okay, I forgot the backslash. Save, and yeah, so the partial is supposed to be like that. So where's the positive and negative come from? Okay, so we see that at least for the element sets, okay, or at least for the element sets, we actually use the OnePort object to actually so-called get these matrix locations. Okay, get this OnePort thing is right here. Where's the OnePort? Okay, PT. Okay, I'm using Vimium right now, so too many tabs open. Okay, let's just open a new class for, here it is. It's right here. What am I doing? Okay, all of these are positive and negative. These are actually what do you call that? The coordinates points for the what do you call it? For the positive and negative nodes. And of course, the last time I was actually having a bit of a difficult time figuring out where these positive and negative nodes are. Okay, but I actually found that out, and I'll hope. The way to find that out is actually quite simple. Okay, if you take a look at these DC analysis examples, and you take a look at the way the circuits are constructed. So let's see. Maybe you have something like this. Yeah, this is a very simple circuit. It has one voltage source right here, one resistor R1 and another resistor R2. Okay, so you look at the voltage source. The way we construct voltage sources are, okay, V1 is the name of the voltage source. We have it connected to an in and an out, and then all of this 1.0. Okay, so somewhere over here within this highlight, this line of code already contains all the information we need to start constructing our Jacobian matrix and our right hand side vector. Okay, so how does this information translate into the matrix construction? Okay, the easiest way is to take a look at the source code behind circuits and voltage source, resistors, all these kind of things. What's going on inside each of these classes? So, well, if we take a look inside the resistor, okay, where are the resistors? I'm just going to take you straight to the resistor source code. Resistor source code is right here, resistor.cs. Resistor.cs here is a partial class. And here's a partial class that inherits from the component thing. Okay, so let's take a look at the constructor. Okay, you'll see actually a few constructors here, few constructor overloads. Normally, if you take a look at this particular one right here, these resistor constructors, they are actually being fed with 3 strings and then 1 double right here. So let's take a look. 3 strings and 1 double. Okay, the first string is then this constructor is likely the one that's being used, the one I'm highlighting. Okay, public resistor, string name, string position, string pos, string negative, double res. Okay, so this first one is the name of the resistor. The second argument is the name of the positive terminal. The third argument is the name of the negative terminal. The last argument is the resistance value. As you can see, the resistance value is being fed into the parameters resistance within the what do you call it, resistor thing, resistor class. Okay, so it's being held within the resistor class. You have a parameters resistance. Okay, the next thing to use is this positive and negative nodes. They are being the connect method here. You see the connect method here is being used to connect this positive and negative node. Okay, and these two are only strings. We don't have any other information from them. Okay, so that the clue as to how these positive and negative connections are being fed in, you have to actually look at this connect code, okay, in order to find out. More importantly for us, we can finally solve the mystery as to which is the positive and which is the negative node according to this example right here. So as you can see, this example right here, for resistor 1 and resistor 2, they are both resistors, obviously. Alright, so what's the positive node for R1? Okay, positive node for R1 is this in here. The negative node for R1 will be out. Okay, this is clearly labeled out. As you can see here, this is out. The node right on the right hand side, so that will be out. And for resistor 2, okay, resistor 2 will have a node coming in. Okay, the name will be out. Okay, the positive terminal will be at this out terminal right here, and the negative terminal will be this 0. So resistors, at least from this example, okay, resistors from this example, we can see that the positive terminal, so I draw a resistor, positive terminal is the one coming in. Okay, so this is the current direction. Okay, positive terminal is the one coming in, negative terminal is the one coming out. Okay, same for voltage source. Okay, voltage source, positive terminal. Okay, here is the positive terminal. Okay, positive terminal is here, negative terminal is here. So interestingly enough, the positive and negative conventions for resistor and voltage source are sort of different. So this is the voltage source, plus and minus, and this obviously is the positive terminal, this is the negative terminal, and the current flows this way. Okay, I'll just leave it as I. Okay, the current flows this way. Alright, so this is there are the two resistors in series. So this is the out, this is 0 volts, this is 0 volts. Okay, so positive is here, negative is here. So we have for resistors, we see that the positive terminal will be over here, the negative terminal will be here. So the convention is kind of different from the voltage source. Okay, based on this code here. Okay, we can of course double check, or rather we should check what is the way constructors how the constructor is being done for voltage sources. So let's look for voltage sources, VSRC. I'll use this voltage source.cs. Okay, again you can see this voltage source constructor is name, positive terminal, negative terminal. So if we take a look at this voltage source here, the first one is this positive terminal, which is the in node. Okay, the in terminal. The negative terminal for the resistor will be the zero terminal, which is at the grounds over here. But technically speaking, this terminal and this terminal are pretty much the same node. Okay, it's pretty much the same node. Okay, so yeah, that's how this very simple circuit is being set up. Okay, so this is of course for a circuit in series. So that's the structure that we use. Okay, So we figured out what is the positive and negative terminal, right? How does that translate? How does that then translate into matrix locations? Okay, so where's the place that matrix locations are determined? Okay, we actually can determine them inside. I'm going to open the behavior tab. Okay, but let me write down first. Okay, I'll put a subparagraph here. Yeah, if you don't like this part, you can skip ahead. Which terminal is positive and negative? So okay, I will just use the example here. URL. Okay, we can see that from the constructor for resistor, the second argument is the name of the positive terminal, and the first argument is the name of the negative terminal. Okay, so this is the constructor here under resistor.cs. Okay, I'll show you. Then we'll just put the constructor here verbatim. I'll just put this is how the constructor is being called. Okay. So what is this constructor here doing? Okay, it's taking the position of the the names of the positive and negative terminals, is putting them into the connect method. The resistance is being put into the rest method, and then you'll see this keyword down here. It's actually calling this name. Okay, so the string name is being fed into another thing. So what's the other thing? So this string name is being fed into this name. Okay, what is this name doing? This name actually is being called. You're actually calling the constructor, because this is the instance of this object, this resistor object, and when you feed in one argument into this resistor object, you're essentially calling the constructor, which is over here. So this is the second. This is the code that is being called first before this code here. So this constructor will be called first. Okay. So it is this constructor here that feeds the name and resistor pin count into the base. What is the base? It is being fed into this component thing right here. Okay, it's being fed into the component class. Okay, so this is how the data actually flows the moment you actually initiate this constructor. Okay, so yeah, but anyway, from this we can see, okay, this code proves the above statement. Okay, then we can look at the diagram shown here. We see that for both resistors and voltage sources, the second argument is the positive node, and the third argument is the negative node. Okay. For resistors, current flows from positive to negative within the resistor. Okay, so current always flows from positive to negative. Okay, so current flows from positive to negative within the resistor. For voltage sources, current also flows from positive to negative, but instead of flowing within the resistor, it actually flows one big round around the circuit. Yeah, so okay, for voltage sources, current flows from positive to negative around the circuit and not really within. Okay, current flows from positive to negative around the circuit rather than within the voltage source. Okay, so the conventions are reversed. Conventions are reversed for resistor and voltage sources. Okay, so the voltage source, I'll just leave the URL here. You can go check it out later. So I'm gonna close this thing. And first thing first, yes, I want to go back to my biasing what do you call that? Biasing source code. And yes, so now we know which is positive and which is negative. We can start looking into the matrices a little bit more. So the variables object is a one-port object which takes in a state and a context. The state here is iBiasing simulation state, and the context is this I component binding context. So a lot of complicated code here. Alright, and if you try to look at the variables object, which is the one port object, and then we look at the get matrix locations method. Let's look at the get matrix location method. Okay, the get matrix locations method actually takes in the IVariableMap. Okay, and then it supplies us these 4 locations within the Jacobian matrix. Again, you need to have your positive and your negative nodes. So what this map does is to take the positive node, okay, the positive node, which is an I variable, and feed it into the map, and then you return the positive integer. And likewise, the negative node, you do the same thing. So how does the map code do that? Well, we can actually look at IVariableMap, and IVariableMap it's over here. So, okay. So I'll put a subparagraph back to how matrices are constructed and how nodes are indexed. Okay, so I'll just put here how nodes are indexed. Indexed. Continued. Okay, so what do we do first? Okay, in the biasing.cs code under resistor. Okay, what happens? The one port type object has a method called what? It's a method called get matrix location. And okay, get matrix locations takes in an IVariableMap. Okay, takes in IVariableMap and returns IVariableMap type object and returns matrix locate indices. So what's this IVariableMap? Okay, what's this IVariableMap? Where does it come from? This IVariableMap actually is somewhat stuffed into the state, which is this iBiasing simulation state. Okay, but if you were to go down that path of looking into what iBiasing simulation state is, you get pretty confused. So let's first talk about the IVariableMap. Okay, let's look in the GitHub here, IVariableMap. Okay, so IVariableMap is actually hidden under iSolver simulation state, but let's take a look at where's the code. Okay, variable map is under simulations variables. Okay, under variables we'll have the variable class, the variable interface, which is right here, IVariablesMap and VariableMap. Okay, so let me just write down what I'm saying here. What I'm saying is that if you actually went down the rabbit hole of iBiasing simulation state, okay, if we go down the rabbit hole of iBiasing simulation state, which contains the variable map, we likely will get lost. Okay, lost in code. So let's just go straight to C, IVariableMap. Okay, we'll go and see IVariableMap first. That's the easier one, and this will be stored here. Okay, this will be stored here. Okay, variable. Then you got to ask what's a variable first. You see that variable is anything with a name and a unit. This actually describes an unknown variable within the system of equations. So these variables will actually just represent, you see this x1, x2, x3. Okay, these are unknowns which you are solving for, and these will be the variables that we need to make an index, so that maybe x1 will be an index 1, x2 will be an index 2, x3 will be an index 3 within this column vector. So that's the idea. Here I want to see how these things are mapped. So this is the class that represents variables. So let's take a look at variable map also. Okay, so this is the variable map class, which I will variable map is here. And IVariableMap is just the interface for this. Okay, and we can take a look. As you can see, variable map implements IVariableMap interface. And the main thing about variable map is that it's a dictionary. It has a dictionary which maps iVariable to some integer right here. Okay, so this is the main thing that's being stored here. Variable map contains a dictionary storing pairs of variable versus their index, which is an integer. Okay, so this is the thing. Okay, so variable map, how is the constructor done? The constructor is done using a ground variable. Okay, the variable map, the first thing in the variable map is the first thing in the variable map that's being constructed is this ground variable. Okay, of the variable map will add a ground variable to the matrix, or to the unknown vector. So this is the unknown vector right here. You add a ground variable to the unknown vector with index 0. So that's the first thing. The ground is the first thing that's added. What's the ground? Okay, ground is, you see these 3 lines here. This is the ground. So when you talk about electrical grounding, it means that the voltage there is the same as the ground. So that's what this grounding is about. Like you have a earthing wire or something, that's what the ground is. And this is the first point that is added to this circuit in this variable map anyway. So okay, so this is the first thing that's added. We begin verbatim, and here's what's being done. Okay, so this is a sort of how IVariableMap works. Okay, or VariableMap works, and VariableMap actually just fulfills this IVariableMap interface, which actually just maps these integers. It stores, okay, variable maps store the name of the node with an index number. So this is an integer. Okay. So next question is, how are variable maps constructed? So we know that for matrices, okay, for these matrices, we know that the index number of the variables will be stored along with the variable themselves in a variable map object. Okay, question: how are these variable maps constructed? I think we'll just tackle that next time. In the meantime, I'll just supply you with all these codes, and know that, yeah, I think I'll just stop for now. I'll see you next time. Okay, bye bye.